Okay, so this is section, well, we're continuing 6.4. So we know how to solve linear inequalities in one variable, and now we want to construct the mathematical model to solve a real-world problem. So you can definitely use this in your other courses if you'd like. So final course grade. To earn an A in your class, you must have a final average of at least, okay, this is an important word that we're going to translate, at least 90% if you want an A. In your first four exams, you have a grade of an 86%, 88, 92, and then 84. Now, on the final exam, it's going to count as 2 grades. So if the final exam counts as 2 grades, what must you get on the final so that you can earn an A in the course? Okay, so step 1, and I gotta put them together. Step 1 and 2 for these inequalities is what is your unknown, right? What don't we know? What are we trying to find? And usually we define it in terms of X. Well, we want to find what must you get on the final, right, to earn an A in the course. So we're going to let X be your grade on the final. Okay, so that's what we're looking for. So that's step 1 and 2. There are no other unknowns in this case. That's why I kind of skipped step 2 or put it together. Step 3 is write an inequality that models the conditions. So we want an equality in X. Well, what do we have? What's given, right? There's a given and the goal. We already wrote the goal. That's X. And the given is we have 4 grades, right? Those are your 4 grades that you received when you took an exam. And on the final, right, you want to get an A, so at the end you want to get at least a 90% average, right, in order to earn that A. Okay, so this is going to be an average, right? That's what we're talking about. And I'm just going to draw this quotient. Now, let me just switch to the arrow. Where's my arrow? Okay, so if you wanted to find the average of these 4 scores, right, you'd add them up and then you divide by 4, and that would give you the average. So I'm going to write 86, 88, 92, and 84, right? And I'm going to add these because I want to find the average. But you're going to take the final and you want, let me change colors, right? You're going to add new scores, right? This is going to be, I guess you can call it green. Well, might as well make this green. I don't want to confuse you with the blue, which counts as 2 grades. So it's going to be X and X, right? If you get like an 80, for example, in the final, that would be 2 80s. Okay, so notice we have 4, your 4 scores plus the 2, so you have 6 terms above. Okay, so you're going to divide it by 6. Now, you want an inequality, right? Well, we have this is an algebraic expression. So your inequality, which I'm going to, let's see, what color should I make this? Let's do this kind of dark purple. So at least 90%. In order to get an A, right, you have to get at least 90% at the end of the class. So that means 90% included, 91, 92, and so forth, right? If you get an 89, you're going to end up with maybe a B or a B plus. So at least that translates to greater than or equal to, right? Meaning you can get, right, that's the equal part. You can get a 90%, but if you get, a 91 or a 92 or a 93, right? You'll be okay. And it's at least a 90, so at least, maybe let me write 90 here. Okay, so hopefully you can see that 90. Okay, so now let's solve this inequality. So we can add these guys, right? That's just the sum of those four numbers. And if you add them up, right, we can simplify this. You're just combining like terms. You're going to get 350 plus, and then x plus x is just 2x. And this is still divided by 6. And this is greater than or equal to 90, right? You have to get at least, that's what that really means, at least a 90. LCD, right? We are going to use the LCD here because we have a fraction. So I can multiply both sides by 6. And this is wonderful because that is gone. And let me go back to black. So we get 350, right, plus x, and I'll just write this in black because x is what we're finding, or green, is at least, and then 9 times 6 is 54, and add the 0. Now there's no more fractions, right? We've cleared, that says cleared, the fractions. We can subtract both sides by 350. Why? Because I want x to be isolated. That's gone, and we're left with 2x, which is greater than or equal to 90, let's see, 190? Yeah, 190. And so 2 times what number is greater than or equal to 90? Well, you can just divide both sides by 2, and let me just move this up. And let's see, that's a big 1. Whoops. That's a big 1, which we want. 1 times x is x. And half of 190 is 95. Okay, this is your inequality, right? Or if you want to write it in set builder notation, let's see, I'll use, what colors do I have? I don't know, maybe this like pink, right? You can do the set builder notation if you want to do that. Okay, so does this make sense, right? This is step 5, right? Check your solution. Does it make sense? Well, let's look at what we have. Okay, so, oops, let me X that out. That's not what I want. Okay, so let me just pinch this. So if we look at the big picture, oops, it's too small. We want to find, and let me get the arrow. Where's my arrow? Okay, the goal is to find x. Well, we just described x right here. We said x has to be at least 95%. So you have to get a 95, a 96, a 97, a 98 on your exam. So when I was describing the purple, right, that's not part of our answer, but that's at the very end, right? I mean, you have to get a 90, 91, 92 after all the exams, right? But on your final, you have to get at least a 95. So again, if you want to visually see this, let's see, I'm going to write 95 right here, 96 and 94, right? I wouldn't write 0, 1, 2, 3 and go, I mean, you can scale it however you want. And again, you don't have to start with a 0. Let's see, I want to use, I guess I'll use green. So I can, and if I want to get an A in this course, I have to get a 95, a 96, right? Maybe a 95 and a half, a 97, 8, a perfect score, right? All these are valid. And again, I'm closing that because that's 95 is included, right? If I get a 94, that's not what I want, different color, right? If I get a 94, I'm not going to get an A in the course. Okay, so let me pinch the screen a little bit. Okay, so there's a big picture, and let me just move this up now. Okay, to check your solution, we are going to, that's not what I want. Let's erase that. Sorry, I'm still getting used to this. Okay, what was our average? Our average was this guy above, right? We have this, the four guys, the four red values. So I'm going to write that out, right? So we had 86, right? Okay, so I'm starting the check up here. Just have some room. So 86 plus 88 plus 92 plus 84. And then what did we just get? Well, it's got to be at least a 95, right? So at least a 95, well, let's just say you got a 96 on your final, right? So that's really two 96s, right? And divide this guy by 6, and then you just evaluate this, right? If you add all the sum right here, you get 542, and if you divide it by 6, right, you can actually write this as a mixed number. You get 9 1/3, or you can say approximately 9.3333, or 9.3 bar, which just means the 3 is repeated. And this makes sense because I just calculated my average, and this number, right, this was greater than, whoops, that is 90.333, not 9, 90 point. That's greater than 90%. So that works. If we pick anything in the color yellow, right? If we pick anything here, I don't know if you can see that yellow, but I'm kind of circling a 94 or even 93. If you plug that in for the 96, you're actually going to get a false statement, which means, okay, it's not greater than 90. I gotta go back and see if I made any errors. Okay, so it's been 12 minutes. Hopefully I didn't talk too much, but I wanted to explain this. This is a very good problem. I'm probably going to do 2 more examples, maybe 1 more, but I think it's going to be 2 more. Okay, let me upload this.